Good morning, dear students. My name is Farhan Mazhar, and the subject we are studying is Cambridge O Levels Physics 5054. In this video, we are going to do an overview of the revision checklist for the topic number 3, whose name is Waves, and this is from the syllabus Physics 5054. So let's start, and here we go. So here in this table, you can see there are 4 columns. And let me explain you how this works. Here in this document, we have provided some revision checklists. These include information from the syllabus that you should revise. They do not contain all the detailed knowledge you need to know, just an overview. For more details, see the syllabus and talk to your teacher. So the first column here, that is of the topic, and this means these are the topics you will study. The second column on which the heading is you should be able to. It has the content in the syllabus you need to cover. Then we have the check boxes. This is the third column here. And you can use the tick boxes to show when you have revised an item and how confident you feel about it. Here R means red, means you are really unsure and lack confidence. You might want to focus your revision here and possibly talk to your teacher for help. A means amber, means you are reasonably confident but need some extra practice. Green means you are very confident. As your revision progresses, you can concentrate on the red and amber items in order to turn them into green items. You might find it helpful to highlight each topic in red, orange, or green to help you prioritize. In the last column, we have comments. You can add further information of your own, add learning aids such as rhymes, poems, or wordplay. Pinpoint areas of difficulty you need to check further with your teacher or textbooks. Include reference to a useful resource. Note that the table which is in front of you cannot contain absolutely everything you need to know, but it does use examples wherever it can. Okay, so in this video, we are working on the topic number 3, which is waves. And the first topic is general properties of wave. You should be able to know that waves transfer energy without transferring matter. Describe what is meant by wave motion as illustrated by vibrations in ropes and springs and by experiments using water waves. Describe the features of a wave in terms of wavefront, wavelength, frequency, crest, which means peak, trough, amplitude, and wave speed. Define the terms. Frequency as the number of wavelengths that pass a point per unit time. Wavelength as the distance between two consecutive identical points, such as two consecutive crests. Amplitude as the maximum distance from the mean position. Recall and use the equation. Wave speed is equals to frequency multiply wavelength, which means V equals to F lambda. Know that for transverse waves, the direction of vibration is at right angles to the direction of the energy transfer, and give examples such as electromagnetic radiation, waves on the surface of water, and seismic S waves, or which we call secondary waves. Know that for a longitudinal wave, the direction of vibration is parallel to the direction of the energy transfer, and give examples such as sound waves and seismic P waves, which we call primary waves. Describe how waves can undergo reflection at a plane surface, refraction due to a change of speed, diffraction through a narrow gap. Describe how wavelength and gap size affects diffraction through a gap. Describe the use of a ripple tank to show reflection at a plane surface, refraction due to a change in speed caused by a change in depth, diffraction due to a gap, diffraction due to an edge. Describe how wavelength affects diffraction at an edge. The next topic is light and reflection of light. Define and use the terms normal, angle of incidence, and angle of reflection. Describe an experiment to illustrate the law of reflection. Describe an experiment to find the position and characteristics of an optical image formed by a plane mirror, same size, same distance from the mirror as objects, and virtual. State that for reflection, the angle of incidence is equal to the angle of reflection, and use this in constructions, measurements, and calculations. The next topic is refraction of light. Define and use the terms normal, angle of incidence, and angle of refraction. Define refractive index, which is represented with the small n, as n is equals to ratio of the sine I to the sine r. Recall and use this equation. Describe an experiment to show refraction of light by transparent glass blocks of different shapes. Define the terms critical angle and total internal reflection. Recall and use the equation n is equals to 1 by sine c, where c is the critical angle. Describe experiments to show internal reflection and total internal reflection. Describe the use of optical fibers, particularly in telecommunications, stating the advantages of their use in each context. The next topic is thin lenses. Describe the action of thin converging and thin diverging lenses on a beam of light. Define and use the terms focal length, principal axis, and principal focus, which is also called focal point. Draw ray diagrams to illustrate the formation of real and virtual images of an object by a converging lens, and know that a real image is formed by converging rays and a virtual image is formed by diverging rays. Define linear magnification as the ratio of image length to the object length. Recall and use the equation linear magnification is equals to image length divided by object length. Describe the use of a single lens as a magnifying glass. Draw ray diagrams to show the formation of images in the normal eye, a short-sighted eye, and a long-sighted eye. Describe the use of converging and diverging lenses to correct long-sightedness and short-sightedness. The next topic is dispersion of light. Describe the dispersion of light as illustrated by the refraction of white light by a glass prism. Know the traditional 7 colors of the visible spectrum in order of frequency and in order of wavelength. Electromagnetic spectrum is the next topic. Know the main regions of electromagnetic spectrum in order of frequency and in order of wavelength. Know that the speed of all electromagnetic waves in a vacuum is 3 expo 8 meter per second. Air is approximately the same as in a vacuum. Describe the role of the following components in the stated applications: radio waves, radio and television communication, and astronomy. Microwaves, they are used for satellite televisions, mobile cell phones, Bluetooth, microwave oven. Infrared, household electrical appliances, remote controllers, intruder alarms, thermal imaging, optical fibers. Visible light is used in optical fibers, in medical uses, photography, and vision. Ultraviolet, security marking, detecting counterfeit banknotes, sterilizing water. X-rays, hospital use in medical imaging, security scanners, killing cancerous cells, engineering applications such as detecting cracks in metal. Gamma rays, the medical treatment in detecting and killing cancerous cells, sterilizing food and medical equipment, engineering applications such as detecting cracks in metal. Describe the damage caused by electromagnetic radiation, including excessive exposure causing heating of soft tissues and burns, ionizing effect caused by ultraviolet, skin cancer and cataracts, X-rays and gamma rays, cell mutation and cancer. Then the topic is sound. Describe the production of sound by vibrating sources. Describe the longitudinal nature of sound waves and describe compressions and rarefactions. State the approximate range of frequencies audible to humans as 20 hertz to 20,000 hertz. Explain why sound waves cannot travel in a vacuum and describe an experiment to demonstrate this. Describe how changes in amplitude and frequency affect the loudness and pitch of sound waves. Describe how different sound sources produce sound waves with different qualities. We also call the quality timbres, as shown by the shape of the traces on an oscilloscope. Describe an echo as the reflection of sound waves. Describe simple experiments to show the reflection of sound waves. Describe a method involving a measurement of distance and time for determining the speed of sound in air. Know that speed of sound in air is approximately 330 to 350 meter per second. Know that in general, sound travels faster in solids than in liquids and faster in liquids and then in gas. Know that in general, sound travels faster in solids than in liquids and faster in liquids than in gases. Define ultrasound as sound with a frequency higher than 20,000 hertz. Describe the use of ultrasound in cleaning, prenatal and other medical scanning, and in sonar, including calculations of depth of or distance from time and wave speed. So, my dear students, these are the revision checklists which are for the topic wave. This is topic number 3 from the syllabus of the Cambridge O Levels Physics 5054. And I hope that this video will help you and you will be able to um, check whether your preparation is on what level. If you find this video useful, if you find this video interesting, please like this video. Please share the link of this video onto your Facebook, onto your Instagram, and onto your Twitter accounts. Because when you like this video and you share its link, this helps me to promote my channel. I think it's a great blessing for me that I can make these videos which can touch the life of so many students around the globe. Thank you very much, everyone, for watching this video. Have a good day, and God bless you all.